In the previous video, we looked at how rowgoals work for queries with, for instance, a top that don't return the full result set. However, there are some cases where a rowgoal might be used where you don't expect it. Let's take a look. Now, when you see a top in a query, it's quite obvious that you will get a rowgoal. But it's not always this obvious. There are other cases where you can also get this rowgoal. Let's once more return to the demo and go to the next example. And what I do here is a syntax that, frankly, I hope you have never heard of it, and I hope you will forget it, but I'm showing it because you might inherit it. It's basically outdated syntax. So you can use the statement set row count with a number, for instance 25, and now, from now on, all queries will have an implicit row goal of 25. So here is the query without a top. This query, when you look at it, should return everything. But because we set a row count of 25 on the connection, and in this case it's the previous statement, but there could have been 20 statements in between. This is remembered for the connection. So everything that happens on the connection now returns at most 25 rows. And even though the execution plan does not show the top operator, set row count works in a different way, the row goal is still there. If I look at the nested loops and look here at the data, you will see that the estimated rows without row goal is there. So this is how you still can see in the execution plan, but you need to look for it. You need to be aware, and as you saw before, it's not always on all operators. So you need to be very aware of this, which is one of the reasons why I believe you shouldn't use set row count. There's many more reasons not to use it. I already said it affects all the future statements on the connection. Are you sure you're not going to forget to disable it? Which reminds me, let's disable it. I don't want this feature. So this is something that can really cause bugs if you set a row count somewhere and then forget about it, and many statements later something doesn't work as expected because it returns more rows than the row count that you set, and then you don't get all the rows. You might not even catch it in testing because your test database might be smaller. It also affects modification statements. Imagine doing an update, and instead of updating all the matching rows in the table, just 25 of them are updated and not all of them. Oh, and by the way, set row count affecting updates and other modifications has actually been deprecated for a long time already. I don't recall whether it was SQL Server 2005 or 2008, but since that time there is a note in the documentation saying, hey, we will change this in a future version, and then set row count will not affect your modification statements anymore. Oh, I'm not going to tell you which version. Let us surprise you by breaking your code. Right, so of course Microsoft adds to that, don't use this feature in cases where you have updates. And I'm going to say just don't use it at all, because even if you look at your entire batch, you might not see the set row count, and it might have been set somewhere else. You're in a stored procedure, but the caller has set the set row count. Or you do use modification and the modified table has a trigger. Do you know which triggers exist on your tables? Well, they are affected by the set row count too. So don't use this. I'm showing it because sometimes you have to work on inherited code. And then you might have an execution plan with a row goal in there that isn't obvious where it comes from. That might be a set row count. Please remove it from your code. There's also another way which is more visible, and I'm going to show that in the last query, and that is the query hint fast with a number. Fast, in this case fast 25, is a hint telling SQL Server, hey, I know that there will be more than 25 rows in this query, or I assume there will be. I want everything, but I want the first 25 rows very fast. Let's execute this and see what happens. And yep, the first rows are there instantly. We didn't have to wait a second that we did before, but the query is still executing. We'll look at how long it took later. But let me first talk about a use case for this hint. Don't use it too much. A use case might be your client asks for data, it has an asynchronous process where it receives the data and instantly starts pushing it to the screen, and then even though only the first page of data is shown at first and it will take some time before the user starts hitting the page down button, you do want that first screen there instantly, and then in the background the application continues to buffer the rest of the data while the user is already looking at the screen and doesn't have to wait for a second or 10 seconds or 20 seconds before that first screen of data appears. So in such a case, it can be useful to say, give me the first 25 rows very fast. But the full description of the fast hint is not just give me the first 25 rows very fast. It is give me the first 25 rows very fast, even at the expense of total query cost. Now, the query has finished by now, and it took 16 seconds to produce all 6 million rows. That's about the same as what we had without the hint, but in this case it was actually SQL Server working hard. If I now look at the wait stats, you will see that async network I/O is only 1.2 seconds. So we actually were working for almost 15 seconds. And if we had used a faster client, then this would actually have affected the query duration. Now, it didn't affect the query duration because Management Studio isn't fast enough, but it did use a lot of resources on my laptop. Now, this is a single person laptop, so who cares? But on your server, do you really want... Oh, I forgot to enable the statistics I/O, but I'll show it in a different way. Do you really want SQL Server to burn through 18 million 18 million logical reads? Do I see that correctly? It's always hard to... They should put points or commas in those numbers. It's 1.8. But 1.8 logical reads for a table with only 6 million rows is insane. This is completely wasting resources. So if you really need those first 25 rows fast enough, you can use this hint, but be aware of the price you pay for it. And again, SQL Server here uses the same mechanism of a row goal. And that is also why, if you look here, it looks as if there's a terrible misestimate. But there isn't. This is not a bad estimate. This is simply a bit misleading because Management Studio shows you the estimated number of rows, which is 25, but that is after applying the row goal. And that row goal is here only to affect the optimization. We want the optimizer to think that we're only going to return 25 rows so that it comes with an execution plan that is as fast as possible for those 25 rows. But then we actually run the execution plan to completion, so in reality we get 6.3 million rows. And if you want to check whether the estimate is correct here, what you do is compare those 6.3 million rows in the actual number of rows with once more the estimate rows without row goal, because the query ran without a row goal. It was only compiled with a row goal. We're deliberately fooling the optimizer because we want an execution plan that's fast for the first 25 rows only. So the top is quite obvious, the fast is also obvious and very dangerous. The set row count can be very tricky, but even this is not the complete list. Sometimes a row goal is introduced by the optimizer in queries where you don't actually expect them. Let's look at the next demo. So in the first query, there is nothing that... Let's just look at the first query only. That's not as distracting. We'll look at the second query later. So in the first query I return some data, and then I have a subquery where I get the maximum order quantity from the sales data based on the same customer ID with an order quantity larger than 3, and I limit this to only territory 3 to reduce the runtime. I could do this for all customers, but let's reduce this. And here you see no top, nothing that would make you think there might be a row goal. But let's look at the execution plan of this query. Now you see a scan of the clustered index with a predicate on territory ID equals 3. That is expected based on the query. And then the cross apply has been translated into a nested loops operator, which joins to the expected join of sales order detail and sales order header here, also with the nested loops. But there's a top there. Why is there a top there? This is very unexpected until you look a bit better at the query. In the cross apply, I compute an order quantity using the max. But then that order quantity is not used in the select. It's also not used in the where. I compute it, but I don't do anything with it. So the optimizer looks at this and says, you're doing a lot of work to compute a maximum and then you're not going to use it. You know what? I'm not going to do that work. So now you might be tempted to say, oh, so we're basically just returning data from the customer table. But beware, this is a cross apply, not an outer apply. That's a big difference, because a cross apply means if nothing is returned from the subset, from the subquery, then that row from the customer table is not returned. So we do need to have a filter. And that is what the optimizer does. The optimizer says, okay, instead of computing this maximum, I'm only going to check whether this query returns anything. And of course you can do that by doing the join and then the grouping. But the optimizer is smarter than that and says if there's just one row, then this grouping will return something, if there's just one row for that customer. If there's no row for that customer, then this will return nothing. If there's one or more, then it will return something. But the or more is not very interesting. Just one is enough. And that is why we get a top here. SQL Server is only interested to see if there's one row that matches the query condition and the join condition that you see here. And if that exists, then the data from the customer table is returned. So actually we are having a kind of a hidden exists condition. We just wrote it in a rather weird way. And this stop introduces the same row goal that we saw before. So again, there will be an estimated rows without row goal here. Why is this 1.63? Because for each execution, SQL Server expects to find 1.63 rows based on certain math things. It's a bit complicated. I'm not going to go into those details. Now, when I say that this query is basically equivalent to an exists, I can rewrite it. Now, the query should return the same results, and I guarantee you it does return the same results. And it should also have the same execution plan, right? Well, surprise! The execution plan is different. There is no top operator. Did we lose a row goal? Well, no. If I look at this nested loops, I still see an estimated rows without row goal property here. And that is also on the index seek here, because that always ripples through. Even without the top operator in the execution plan, you can get a row goal. Now, why is this row goal here? That is because now the nested loops operator has been made a left semi-join. And all semi-joins, left semi, right semi, left anti-semi, and right anti-semi, all those join types with semi in the name basically mean just stop looking as soon as you found the first match. We don't care how many matches there are, one is enough. And that means that the row goal is implied. The semi-join logic of the nested loops will stop asking for more rows once the first row is found. So you don't need a top operator. It's basically hidden in this nested loops once it does any kind of semi-join. That is not the case for merge, join and hash match, by the way, but for a nested loops, that is how it works. So basically the same execution plan, but now the top is not visible. The row goal is still there. And again, you need to be aware that the semi-join basically implies a row goal if you have a nested loops. And that's it. In the next video, we will look at the dangers of a row goal, because as good as it seems, this feature may sometimes backfire. Bye bye.